series. Okay. Now, before we begin, let's quickly have a glimpse, a look at our tutorial. Okay. Hello.
This video is about the reactivity series of metals. Metals can be listed in order of their reactivity, and this is known as the reactivity series. Whilst carbon and hydrogen are not metals, they are often shown within the reactivity series as they can be used to extract metals from their compounds. This is not an exhaustive list, as many other metals exist which are not shown here. You need to make sure that you learn the order of the reactivity series. The order of reactivity of metals can be determined by reactions with water and acids. Here are the reactions of metals with water. The most reactive metals will react readily with cold water, and the reactions become less vigorous as we go down the reactivity series. For potassium, sodium and calcium, the reaction with water produces the metal hydroxide and hydrogen gas. Metals just below calcium will react slowly with cold water, but will react with steam. In the reaction with steam, the metal oxide and hydrogen are produced. Note how the word equation does not use the word steam, as this is not the name of the compound. Copper, silver and gold do not react with either cold water or steam. You need to be able to describe the reactions that are highlighted, so make sure that you learn these. Here we can see the reactions of metals with acids. The more reactive metals will react violently with acids, so these reactions are typically not undertaken in a laboratory. Only the metals above hydrogen will react with acids to form a salt and hydrogen. During the reaction, you would observe effervescence as bubbles of hydrogen gas are produced. The more reactive the metal, the more vigorous the effervescence. You can see the word equations for the reactions of metals with hydrochloric acid here. You need to be able to describe the reactions that are highlighted. The reactions of acids are limited to hydrochloric acid, and you should know that copper, silver and gold do not react with hydrochloric acid. Let's look at some typical exam questions relating to the reactivity series. The first question focuses on your ability to recall the equation of magnesium with steam. Magnesium has the symbol Mg and is a solid, so its state symbol is S. Steam is the gaseous form of water, so its formula is H2O and its state symbol is G. Therefore, we can write the reactants as shown here. Magnesium is less reactive than calcium, so it will form magnesium oxide and hydrogen. You should know the formula of both of these compounds. Even if you don't know the state symbol of magnesium oxide, you can work it out from the question, as it tells you that a solid and gas are formed. You should know that hydrogen is a gas, therefore magnesium oxide must be the solid. Don't forget to check that the equation is balanced, which it already is. There are 2 marks awarded for a correct answer. You will gain 1 mark for the correct formulae of the reactants and products, and 1 mark for the correct state symbols. The second question is testing both your recall of the order of reactivity and your knowledge of the reactions of metals with acids. You should know that the metals iron, copper, silver and gold are all beneath zinc in the reactivity series, and that any metal below hydrogen will not react with acids. Only iron is above hydrogen, and copper, silver and gold are all below. Therefore, the only metal that will react less vigorously than zinc is iron. This next question requires you to apply your understanding of the reactivity series. To deduce the order of reactivity, you need to use the observations. When metals react with acids, effervescence is observed as bubbles of hydrogen gas are produced. Copper produces no effervescence, and it does not disappear. Effervescence is observed in all of the other reactions, so copper must be the least reactive. Calcium must be the most reactive metal, as it effervesces the most vigorously and it disappears quicker than the other metals. This means the order from the least reactive is copper, iron, then calcium. Be careful that you list them in the correct order. It is a common mistake for students to list them from the most reactive to the least reactive. The observations do not show a difference in reactivity between magnesium and zinc when reacted with hydrochloric acid. Part B asks you to suggest an additional experiment that could be used to determine which is the more reactive. You should recall that the order of reactivity is determined experimentally by the reactions of metals with acids and water. So a sensible suggestion would be to react them both with water to see if there is a difference in reactivity. You would also be awarded the mark if you said react with oxygen or air, as the more reactive metal will react with oxygen more rapidly. In summary, the reactivity series shows the order of reactivity of metals, and you need to learn this order, including carbon and hydrogen. The order of reactivity is determined experimentally from the observations of the reactions between metals with water and acids. You need to be able to describe and give the equations for the reactions between the reactants listed here. Remember that copper, silver, and gold do not react with hydrochloric acid. Don't forget to check out all our other fantastic revision resources here at Save My Exams.
Okay, so we've seen the tutorial, and let's quickly go through the material. Okay, so we've understood what is reactivity. So we arrange metals with the exceptions of carbon and hydrogen that are no metals that are part of the reactivity series. Every other element that is in the reactivity series is a metal. Only two elements or two atoms that are in the reactivity series that are no metals are the carbon and the hydrogen. So we're going to look at the reactivity series and see how the elements react, or which are more vigorous in reactions with cold water, reactions with steam, and reaction with gas, and even probably with reaction with oxygen. Now we say the chemistry of metals, we've already looked at it, right? And we've looked at the reactions they undergo with cold water, with steam, and with acid in our previous video in part 12 of this chapter, right? Now, based on what we have seen in the reactions in the past, when the metals react with acid, or metals react with cold water, or metals react with steam, we're able to deduce a series of metals can be produced, right, from, or series of other products like salt can be produced. And gas, hydrogen gas, can be produced from the reactions we've seen in these cases. Now, the series can be used to place a group of metals in order of reactivity based on the observation that we're going to see, or we've seen previously when metals react with water or metals react with acid. Now, let's quickly take a look at the metals and their order of arrangement. We start the first one, or the highest in reactivity, because it's the order of reactivity is going up the group like this. It's increasing as you go up. The top one is the most reactive. Okay, the order of reactivity is going up. It's increasing as we go up the chart, right? It's increasing as we go up the chart. This is the order of reactivity, so it's increasing. So this is the least reactive. What it means is that gold, which is at the bottom, is the least reactive, and the potassium, which is the first one on top, is the most reactive. So now let's take a look at the reaction with cold water. Reaction with cold water, and reaction with acid, and reaction with oxygen in each of these. For example, if you take potassium, remember the symbol of potassium is K. Okay, the symbol is K. If you take potassium to react with water, if you say it reacts with water, you get what? It reacts very quickly, right? Or we can say violently, meaning it's very rigorous. Okay, it reacts violently to form potassium hydroxide. So it reacts violently when potassium reacts with cold water. And when it reacts with acid, same thing. When potassium reacts with acid, maybe hydrochloric acid, to form potassium chloride and hydrogen gas, it also reacts very violently. So because it's the most reactive, remember that. Potassium is the most reactive. So it reacts very violently with cold water, very violently with acid, and reacts very quickly with water to form potassium oxide. Now the second on the list is, this is the top one. So I don't know whether we should call it number one, because it's the top one. Okay, we can call it number one. It's the top one. This is our number two. Okay, sodium is the next one. Sodium reacts quickly with cold water, reacts very quickly with acid, also reacts quickly with air. So it reacts with cold water to form sodium hydroxide, and hydrogen gas, right? It reacts very quickly with cold water to form sodium hydroxide. So when metals react with cold water, they form metal hydroxide and hydrogen, right? They form metal hydroxide and hydrogen gas. So sodium reacts with cold water. Sodium, the symbol is Na. Okay, you'll be wondering why is the symbol Na. At least if you're in grade 11, you should have grade 10, grade 11 should have dealt with this. This is from its native name. Okay, the Latin name, which is Latium. Sodium, the Latin name is Latium. So the symbol is derived from the Latin name, so Na. So when sodium reacts with cold water, like H2O, okay, I'm not focusing on balancing the equation. When sodium reacts with water, H2O, it will form what? Sodium hydroxide plus hydrogen gas, right? Form sodium hydroxide, okay? A metal hydroxide will be formed because when metal reacts with cold water, it forms metal hydroxide, so sodium hydroxide. Sodium hydroxide is like this. You're going to have something like this, NaOH, okay? NaOH, and then plus hydrogen gas. NaOH plus hydrogen gas. Then you can balance. You can do the balancing as it were, okay? Now this is a gas. Sodium hydroxide is an aqueous. The hydrogen gas is a gas, okay, as it were. And this is aqueous and so on and so forth. So you can balance the equation as it were, and this is the symbol that shows the reaction. Now when it reacts with acid, like hydrochloric acid, it will form what? Sodium chloride, like a salt. It will form a salt, sodium chloride, and hydrogen gas, right? You react with oxygen, sodium react with oxygen, we form sodium oxide. Form sodium oxide. Form sodium oxide, which is a basic oxide. Sodium oxide is a basic oxide. Is that okay? Now let's calcium, the third one, which is number 3. When it reacts, it will react less strongly compared to the first two, but still strong, but just that less strongly compared to this first two. So calcium reacts with cold water to form calcium. This one is always in your exam. Calcium reacts with cold water. Cold water to form calcium hydroxide. Now calcium hydroxide, how do we write it? This one is always in the exam paper. Okay, react with cold water to form what? Cambridge exam, Cambridge Igcse exam. So to form this will form calcium hydroxide. This will form calcium hydroxide. How do you write calcium hydroxide? It's CaOH, then bracket 2. And this one I show in the previous class how we get this CaOH bracket 2. How do we get this? I said that if you know, you use the ions of metals, calcium, it gives out 2 electrons. So you write plus 2. It gives out 2 electrons. So I write plus 2 other. You know the plus 2 is top here, but I just decided to put it here. Then OH has a -1. OH has a -1 ion. It's together as this thing. So it has a -1 ion. So when we cross multiply, we don't take cognizance of the signs. We just use the numbers. So I cross multiply 1 with calcium. I cross multiply 2 with the OH. So calcium times 1 is just calcium Ca. Calcium times 1 is calcium Ca. I'm just doing an overview of what we did in the previous class. There are 2 times OH. I'll write the OH. Remember the 2 is multiplying the OH together. So don't write OH2. If you write OH2, you fail it. So you have to put bracket to show that the 2 is multiplied both O and H. To show that this 2 is multiplied both O and H. So this is why calcium hydroxide is written like this. So you produce calcium hydroxide and hydrogen gas. So this is always in the exam. Remember this, okay? This is always in the exam. One of the reaction with cold water, okay? When calcium reacts, if they say water, even if they don't say cold water, they're talking about cold water. Sorry, this is not water. Okay, this is hydrogen gas. This one is hydrogen gas. Okay, so when they say water, they're talking about cold water. If they mean otherwise, they will measure steam. Or water vapor. Either they use the word steam or water vapor, then you know they're talking about the hot water. So when you react with acid like calcium, react with hydrochloric acid, for example, you form calcium chloride. If you react with sulfuric acid, you form calcium sulfate. If you react with nitric acid, you form calcium nitrate, right? So it depends on the acid you react with, that determines the kind of salt that will be produced, and hydrogen gas. So it produces salt and hydrogen gas. Is that okay? Then when you react with oxygen, form calcium oxide, very readily, very fast, very quickly. Is that okay? Now we'll go to magnesium number 4. Magnesium does the same, but magnesium, slow reaction. Is a little bit slow in the reaction with cold water. Slow. But react with steam very fast. You know, when you react with steam, you form magnesium oxide. Doesn't form magnesium hydroxide. Form magnesium oxide. Anything react with steam, the metals react with steam, they form oxide. Metal plus steam form metal oxides. Okay, but when metal reacts with water, cold water, slowly, eventually to form magnesium hydroxide, form magnesium hydroxide plus hydrogen gas. But when you react with steam, it form magnesium oxide and hydrogen gas, right? When you react with acid, you react very vigorously, very fast. With hydrochloric acid, you form magnesium chloride. With sulfuric acid, you form magnesium sulfate. With nitric acid, you form magnesium nitrate. Is that okay? Yeah, magnesium, when magnesium reacts with oxygen, just magnesium oxide. MgO, form magnesium oxide. When you react with oxygen, when you react with oxygen, just form magnesium oxide. Is that okay? Now we go to the next one, which is aluminium. So these are the first 5 ones in the reactivity series. They are characterized because they can be extracted from their ore using the electrolysis method. These first 5 in the reactivity series can be characterized or can be obtained from their ore in the earth crust using the electrolysis method. Now we go to aluminium. Aluminium is extracted from its bauxite. It's extracted from its ore, which is bauxite. Bauxite has the most of aluminium, right? Okay, it's the ore natural, which means aluminium 3 oxide. Okay, aluminium 3 oxide is the bauxite. It's called bauxite, the ore of aluminium. Now, when aluminium reacts with water, with cold water, it's very slow. It's very slow to produce aluminium. Hydroxide. It's very slow. But react with steam to produce aluminium oxide. React very fast with steam to produce aluminium oxide and hydrogen gas. Then react with acid very fast, readily, quickly to produce aluminium chloride, aluminium whatever. It's okay, aluminium sulfate, aluminium nitrate, and so on and so forth. React with oxygen to form aluminium oxide, aluminium 3 oxide. Is that okay? Aluminium 2 oxide, aluminium 3 oxide. So when you react with oxygen. Now after these first 5 are characterized by what? They are called the most reactive in the reactivity series. So you have to know potassium, sodium, calcium, magnesium, and aluminium. Potassium, sodium, calcium, magnesium, and aluminium. So aluminium is the least of the first 5, and potassium is the first of them all. Potassium, you have to commit in your memory. Potassium, sodium, calcium, magnesium, aluminium. Is that okay? Okay, so these are the first 5, and these first 5 are obtained by electrolysis. Allah, Almighty God, when He created this life, this earth, planet Earth, He put a lot of mineral resources and a lot of metals. Metal, we cannot survive without metals. We cannot build our cars without metals, refrigerator without metals, aeroplane without metals, our cooking utensils, can for preserving food, and all of these things we cannot do without metals. So we need metals to create the life that we want to live, the life we want to see. Now, as a result of that, these metals were put in the earth by Almighty God. We are put in the earth. We have to look for it. We have to look for them. So when we look for them, we don't just find them in the pure state as metals. We find them in their ore. We find them in their ore, and we have to extract them and purify them and then use them. So one of the ways of getting them is electrolysis, especially these first 5. We use electrolysis to purify them from when we dig them from the ground. We use electrolysis to extract them and to get the metal out of its ore. Electrolysis. So electrolysis is used for these first 5. The next 4 or 5 electrolysis. The next 4 or 5 is reaction with carbon. Now after this 5, the 6th one is carbon. Okay, the 6th one is carbon. Carbon is not a metal, so it does not have this characterization. Although the allotropes like graphite, when in molten state, can conduct electricity, but diamond does it. Okay, now let's move on to the next one, which is zinc. So the next phase, these 3, we can get them by doing what we call this set. We can get them by doing what we call reaction with carbon. Okay, oxidation reaction with carbon. Reduction reaction with carbon. Reduction reaction with carbon. This is how we get this next one. Reduction up to this place. Okay, up to silver. Up to silver. Okay, up to silver. Only gold. Gold is in a pure state. If you dig the ground, what you find is gold. You don't need to purify. Gold is gold. Once you dig the ground, you don't need to carry out electrolysis, you don't need to carry out reduction reaction. So one of the exam questions they can ask you is, which method do we use to obtain our metal such as zinc, iron, copper, and silver? Which method? We use reduction reaction with carbon. Reduction reaction with carbon. So when you react them with carbon, a reduction process would have occurred, and then you get the metal from its ore. You get the metal from its ore. Okay, reduction reaction with carbon. Okay, so this is the second phase. The last phase is just gold. Gold does not need purification, does not need just dig the ground, and then you find gold, and then it's gold. You just clean it. If you find sand in it, just dust the sand out of it, clean it, dust it, wash it. That's it. You don't need to, it's not in any form with anything. That's why when you react it with steam, nothing happens. No reaction with steam, no reaction with water, no reaction, no reaction, no reaction. In all, no reaction. But why silver can? Because silver can react with oxygen to form silver oxide, But it doesn't react with acid. Silver does not react with acid and does not react with water or steam. But it reacts with air. It can react with air. You know, when we say oxygen, we're talking about air. Is that okay? Air is a component, one of the major components of air. Oxygen is one of the major components of air. So to obtain this one, we carry out oxidation reaction with carbon. We're able to get zinc, iron, copper, and silver. Zinc, iron, copper, and silver. But after iron, we have another non-metal called the hydrogen. After iron, we have another non-metal called the hydrogen. So hydrogen is below iron, but it's higher than copper in reactivity series. So when we carry out electrolysis, ions that are less, for positive ions that are less than hydrogen in the reactivity series will be the one that will migrate to the cathode. The one above hydrogen will not go, hydrogen will migrate. For example, if I have ions such as calcium, if I have calcium and I have hydrogen ion, for example, if I have calcium ion 2 positive and I have hydrogen ion, which one will migrate to the cathode? Which one will migrate to the cathode? Due to electrolysis. We're going to study electrolysis again, okay? We're going to study electrolysis. Which one will migrate to the cathode? If you have this, a mixture of this, and if we have SO4, if we have SO4 2 minus for the negative ions, SO4 2 minus, you know, the ions that are found in your electrolyte, when your electrolyte dissociates. And let's say we have OH, ions. Okay, these are the ions that we find when our electrolyte dissociates. Okay, now the positive ion will migrate to cathode, and the negative ion, these 2 negative ions, will migrate to the anode. These 2 negative ions will migrate to the anode. This and this will go to anode. Anode is the positive electrode. This one will go to anode. This one will migrate to anode. While the positive ion will migrate to the cathode during electrolysis. Okay, we are not doing electrolysis, but we'll just give you an overview. This one will migrate to the cathode. The positive ion will migrate to the negative electrode called the cathode. So this one will migrate to the cathode. Right? Now, but not both of them that will migrate at the same time. Only one of them will go. Which one will go? Now, when you have calcium is higher. Look at the reactivity series. Calcium is way higher than hydrogen. Now, the rule is that the one that is lower is the one that will go. It's just like a younger brother and a senior brother. Which one will go and bring water? Which one will go for the message? It is the younger one that will go for the message. So hydrogen will go. Hydrogen will be the one that will go for the message, that will migrate to the cathode to go and do whatever they want it to do there. Calcium, because it's higher, calcium will not go. However, if you have hydrogen and silver, or hydrogen and copper, if you have copper ions, and you have hydrogen ion, which one will migrate to the cathode now? Which one will go? Migrate to the cathode. Which one? Because hydrogen is higher now in this regard, it's not a senior brother, it's a big boy. It's higher than copper in the reactivity series. hydrogen will not migrate. It will sit back and tell copper, hey, you go to the cathode and go and do whatever they ask you to do there. So if you have between hydrogen and copper, hydrogen will not migrate to the cathode. It is copper that will migrate to the cathode. It is copper that will migrate to the cathode. Okay, not hydrogen this time around. But between calcium and hydrogen, it is hydrogen that will go. It is hydrogen that will go. Is that okay? It is the one that is lower that will go. Between hydrogen and silver, it is silver that will go because hydrogen is higher. Is that okay? So these are the basic knowledge we will just want you to have slowly with regards to this. Now let's move to the next one. How to react the reactivity, how to remember the reactivity series. We have a short way of remembering the reactivity series. Okay? We have to, just like the way we develop a song for the first 20 elements in the periodic table, we also have a small song to remember the reactivity series. The first one is potassium, second one is sodium, third one is calcium, fourth one is magnesium, fifth one is aluminium, carbon, zinc, iron, hydrogen, copper, silver, and gold, right? So now we have a small song to help us remember them. Now the song goes like this. Please send cats, monkeys, and cute zebra into hot countries, signed Gordon. Please, the song is, please send cats, monkeys, and cute zebra into hot countries, signed Gordon. Okay? You can use any name that starts with G that you know. Okay? If you don't like Gordon. Like me, I don't like Gordon. So, you can use any name. George. You can use George. You can use any name that starts with G if you don't like Gordon. But the song is, please send cat, monkeys, and cute zebra into hot countries, signed George. Is that okay? So if you remember this song, it's easy to remember and write all the methods according to the reactivity series. Is that okay? Please send cat, monkey, and cute zebra into hot countries, signed George, or signed Gordon, signed whatever G name you have. Is that okay? Okay, so what it means is that the please is for potassium, the P is for potassium, the S is for sodium, the C is for calcium, the M, which is monkey, is for magnesium, A, which is for ant, is for aluminium, the C, which is cute, is for carbon, the Z, which is zebra, is for zinc, the I, which is into, is iron, the H, which is hot, is for hydrogen, the C, which is country, is for copper, and this S, which is sign, is for silver, and the G, which is Gordon, is for gold. So this is the least one, the least reactive, and the top one is the most reactive. Okay, the top one is the most reactive. So meaning the reactivity is like you move it, is increasing as you move up. The reactivity is increasing as we what? As we move up the group, as we move up this reactivity series. So this is the most reactive, and gold is the least reactive. So we'll move on. Okay, remember this class is basically for reactivity series. Now we'll go to reactions of metal with cold water. I think we've done this one in part 1, so we will just go through the equation together. When metal react with cold water, they form metal hydroxide. They form what? Metal hydroxide. They form metal, let's look for something different. They react with water, they form metal hydroxide and hydrogen gas. Right? Now let's see some example. Calcium is solid, react with cold water, we form calcium hydroxide. This is always in the exam, like I said. Always in Igcse exam paper. This one, Cambridge Igcse exam paper. Okay, please take note. Do not fail what you know. People fail what they know, they're not going to pass the exam. Because you definitely fail what you don't know. If you keep failing what you know and you fail what you don't know, you've failed already. So please take note. Calcium solid react with cold water to form calcium hydroxide. I already explained how we got this one, which is an aqueous plus hydrogen gas. You need to put state symbol. If you don't put state symbol, you not get. And you need to balance. There are 3 things. You are able to write the equation correctly. You are able to balance it, and you are able to write the state symbol. Calcium, you put solid S, small bracket. Water is liquid, you put bracket. Calcium hydroxide is aqueous, you put bracket. Okay. Most alkali, most acid, and most salt. They are aqueous. I already told you that. Then hydrogen is a gas, pure gas. Then you get your 3 marks. Usually they give 3 marks. So you're able to write the equation 1 mark, balance it 1 mark, and put the state symbol another 1 mark. That gives you 3 marks. Now another one, potassium react with cold water to form potassium hydroxide. This one you see, there is no K bracket 2 here. There's no bracket 2 here. It's only this 2 is for balancing, but there's no 2 here. Why? Because potassium has 1 ion. OH has potassium has +1. You know, potassium has +1, and the OH that is going to form with has -1 together. This OH has -1 together. Okay, -1. So if I cross multiply, the 1 here multiplied by this will still be K. The OH times this one, like this one times this, and this one times this. So this it will KOH. That's why potassium hydroxide is this. The 2 at the back, the 2 is the coefficient, is the molecule, number of molecules for balancing. This 2 is from balancing the equation, when we were balancing the equation. Okay? And you know, we also put 2 here for potassium to be 2 atoms of potassium, 2 atoms of potassium here also. That is balanced. You have to check the number of atoms. 4 atoms of hydrogen here. Now you check here. This 2 times 1 is 2 plus this 2, that's 4. Hydrogen is balanced. Oxygen is what? 2 times 1, 2. 2 times 1 here also 2. So oxygen is balanced. So this equation is balanced. You must learn balancing or practice balancing. I know you know it, but you have to practice balancing. So that's that reaction with cold water. Now reactions of metal with steam. Steam means hot water. Remember, anytime metals react with steam, hot water, they only go to form metal oxide. Only metal oxide. For example, if you take magnesium reacts with hot water. Hot water will put gas because steam is water vapor. You will be wondering, oh, water will put gas, water here will put liquid. What? Why? Because this is steam. This is hot water. This is boiling water. It's no more water. It's a gas. It's water vapor. So this water vapor reacts with magnesium, which is solid, will form magnesium oxide. Magnesium oxide is a solid. This time around, it's not aqueous. It's not aqueous. Most bases are solid. Okay, it's not aqueous. Magnesium oxide is an aqueous substance. It's a solid substance. There plus hydrogen gas. Is that okay? Plus hydrogen gas. Is that okay? If they ask us to write the half equation, we should know how to write the half equation. Is that okay? Okay, now reaction with dilute acid. With dilute acid, that means acid that is mixed with water. When they say dilute acid, the acid has been mixed with water. Let's take a look at some of the acids. Okay. When metals react with acid, they form salt and hydrogen gas. We already established that many times in the part 1 of this video. Now let's take a look at this. Magnesium as an element react with sulfuric acid, H2SO4. You must know all these acids and how to write them. Sulfuric acid is H2SO4. The AUPAC name from the AUPAC nomenclature is tetraozosulfate 6 acid. Tetra means 4. Tetraozosulfate 6 acid. You read it from this way. But in Cambridge Igcse, we don't bother. In A level, you start to do the AUPAC naming. But here, we don't bother with the AUPAC naming of the acid. We just call it sulfuric acid. Okay? We have hydrochloric acid, sulfuric acid, nitric acid. I think these are carbonic acid. These are 4 popular acids that you will use for your IGCSE. So when metal react with sulfuric acid, they will form what? Metal sulfate. They will form a metal sulfate salt, which means if it is magnesium, it will be magnesium sulfate. Is the SO4 that is the sulfate? The SO4 will be the one. The magnesium is higher than hydrogen in the reactivity series. You can come back and see. Magnesium is higher in the reactivity series. Let's check the reactivity series one more time. Magnesium, okay, it's even here. Magnesium, look at it. Magnesium is higher than what? It's higher than hydrogen. You know, if you are higher in the reactivity series, you can displace the one that is below you. You can displace, okay? You can tell it to stand up, you sit because you are the big brother. You can tell the element or the metal to stand up for you because you are the big brother. Magnesium is higher than hydrogen. So what magnesium is going to do, magnesium will tell this hydrogen to stand up. And magnesium will combine with oxygen. It becomes magnesium oxide. And then this hydrogen will be on its own now. Will be on its own. Will stand up and be on its own. Okay, that's the meaning of this metals, how they displace themselves in the reactivity series. Now we move on to the acid. Magnesium reacts with sulfuric acid. This magnesium will displace this hydrogen and it become magnesium sulfate. That's how we got this salt. That's how we got this salt, magnesium sulfate, and this hydrogen will form hydrogen gas on its own. We become an hydrogen gas. So when magnesium reacts with sulfuric acid, we form magnesium sulfate, which is a salt. We call it sulfate salt. We call it sulfate salt plus hydrogen gas. Then when magnesium reacts with hydrochloric acid, HCl, you must know how to write each of these acids. When we say hydrochloric acid, HCl, you must know how to write HCl, hydrochloric acid. Magnesium reacts with hydrochloric acid, magnesium will displace this hydrogen. These two at the back is just for balancing, okay? It's after you finish the equation that these two came about. It's when you were balancing the equation these two came about, okay? This two was not there originally. So you say magnesium reacts with hydrochloric acid, magnesium will displace this hydrogen and it will become magnesium chloride. It will become magnesium chloride. Why is there two here? You know, I keep telling you, magnesium has two electrons in the atmosphere. So which means, you know, the number of electrons in your atmosphere is the number of electrons the metal will give out. Is the number of electrons the metal will donate. So it gives 2 electrons, it becomes magnesium 2+. Chlorine has only 1. Chlorine has what? Only 1. Chlorine has only 1. And that one not have 1. Chlorine is looking for 1. You know, when you're looking for, you become minus. Chlorine is looking for 1. It has 7 in the atom shell. It's looking for 1 to complete 8. So it becomes -1. So when we cross multiply, let's do the cross multiplication. Before you begin to wonder, how did the formula became like this? We're showing you how the formula became like that. So when you cross multiply this one, multiply by magnesium, 1. I said don't use the sign, just multiply the numbers. 2 multiplied by chlorine. 2 multiplied by chlorine. What we go to get? We're going to have 1 times magnesium, we just have Mg. We just have Mg. You know, anything 1 we don't write in math or in physics or in chemistry. And then chlorine, 2 multiplied by chlorine, I have Cl2. I have Cl2. Remember this, okay? This is a simplest thing that you should know by now, okay? That you should understand how this thing works in chemistry. Once you know this thing, chemistry is very easy, okay? So magnesium, when magnesium reacts with chlorine, it becomes magnesium chloride and hydrogen gas. Because this one has H2, we have to balance by putting 2 here, and this chlorine has 2 also, we have to balance this one by putting 2. Magnesium is 1 here, magnesium is 1 here, we don't need to put 2 in this way. Now when we take another one which is less than magnesium in the reactivity series, which is zinc. Zinc is even less than carbon in the reactivity series. Now, okay, zinc is less than carbon and followed by iron. Zinc is higher than iron, right? So we say zinc react with sulfuric acid, you're going to form what? Zinc sulfate. You're going to form what? Zinc sulfate. Because zinc will displace the hydrogen. Zinc will tell hydrogen, I'm higher than you in the reactivity series, please stand up for me. Zinc will displace hydrogen, it becomes zinc sulfate. It becomes what? Zinc sulfate and hydrogen gas. It will form zinc sulfate and hydrogen gas, right? A salt, a zinc sulfate salt, and hydrogen gas. That's when it reacts with sulfuric acid. When it reacts with the same zinc reacts with hydrochloric acid, it will become what? Zinc chloride. It's the same thing I did here. Zinc has 2+, so when it cross multiply, it will become ZnCl2. You should remember that. You should remember how we got this, plus hydrogen gas. Then we go to iron. Iron is also higher than hydrogen in the reactivity series. So iron will tell this hydrogen, please stand up for me, I'm your senior brother. So it becomes iron sulfate. It becomes iron sulfate, and this hydrogen that stood up will be on its own, become hydrogen gas. So that's how we got this salt, iron salt. Okay? So that's how we got this salt. Now, in the same vein, when iron reacts with hydrochloric acid, it forms what? Iron chloride. The same thing that I've explained here, because iron has 2+. So you get iron chloride plus hydrogen gas. Is that okay? So this reaction with dilute acid. Now let's take a look at the reaction with oxygen, which we've looked in the previous case. We said that gold do not react with anything. Gold do not react with whether acid, cold water, hot water, or not even high oxygen. Okay, but silver managed to react with oxygen. But silver does not react with water, does not react with cold water, steam, does not react with acid. Okay, so now let's take a look at reactions with oxygen, especially the most reactive one in the reactivity series. Metal plus oxygen will be what? Metal oxide. For example, copper plus oxygen, copper oxide, right? That's it. Gold does not react with oxygen. Yes, gold does not react with anything, not only oxygen. Gold does not react with oxygen, gold does not react with cold water, gold does not react with acid. So if you put acid in gold, nothing will happen to the gold. If you put cold water with gold, nothing will happen to the gold. If you put hot water, very hot water in gold, or put gold in hot water, nothing will happen to the gold. Okay, so gold does not react with. If you bring oxygen close to gold will. That's why gold does not rust. That's why if you go and buy gold chain, gold necklace, gold earring, it does not rust. Why? Because it does not react with oxygen, does not react with water. You know, rusting is facilitated by what? By water and oxygen. Rusting or corrosion is facilitated by water, reaction with water, and reaction with oxygen. Gold do not react with oxygen, gold do not react with water, therefore gold do not rust, gold do not corrode. Is that okay? Gold is unique, gold is a blessing, gold is wealth. When you have gold, you're wealthy. When you have gold, you're wealthy. Okay, we move on to the next one. Then this is the order of reactivity, so that we can wrap up quickly. Now, the order of reactivity of metals can be deduced by making experimental observations of reactions between the metals, water, oxygen, every of these three characterizations or four characterizations I've mentioned. So the one that can react with all of them very strongly, they are the most reactive. The one that can react with cold water, with steam, with acid, with oxygen, four of them. The one that can react very vigorously, violently, strongly, rapidly. The one that can do this, they are the most reactive one. They are called the most reactive metals in the reactivity. And they attempt the top, like potassium. Potassium has this characterization, is able to react violently with cold water, able to react violently with steam, which is hot water, is able to react violently with acid, rapidly with oxygen. So as a result, is the most reactive. So how fast or how quickly or how rapidly or how violently you react with all these four characteristics is how we arrange you in the order of reactivity. Is that okay? The less you have, then the more you go down in the arrangement chart. This is how we determine the reactivity of them. Thank you for joining us, and we'll see you in our next section.